Hello, everybody. Mr. Rubo here. We got topic 212, logarithmic function manipulation. So we had one where it was exponential function manipulation. Logs and exponentials very similar. Obviously, they're in inverses. So a lot of the same properties we have for exponentials, we have similar properties for logs, and we can use those to manipulate log expressions to form equivalent expressions. So we have the product property, the quotient property, and the power property. There are more properties, but these are the ones we're going to hit in this video and just in general. So product property is when you have the product or the multiplication inside of a log, you can break it up using two separate logs and addition. So you'll notice the base stays the same, but then x and y got split up. Okay, so we're going to do the same idea here in this example. Log base 2 of 5x. Well, I can separate it as log base 2 of 5 plus log base 2 of x, because 5 times x I can break up. Okay, quotient property, very similar. Well, if multiplication gave us addition, what ends up happening here is we get subtraction. Okay, technically these two properties are the same, if you will. It just deals with negative exponents, which we'll talk about with the power property, how we can actually use the same. But again, multiplication gave us addition, division gave us subtraction. Multiplication gave us addition, division gave us subtraction. So log base 3 of y minus log base 3 of 4. These two things are equivalent. All right, then our power property. This is a very, very useful one. So what this power property does is it lets us take this power and move it out of there. So it ends up, we get to move it to the front. So it ends up being n times log base b of x is the same thing as saying log base b of x to the n. All right. And where this is really helpful is in examples like this one, where we have log base 7 of 3 of x. Well, we don't like having x's in our powers, so we pull it to the front. So it'd be x times log base 7 of 3. Okay. And yeah, that's the three main properties we're going to deal with, and that will help us solve. All right. So we're going to see this where we have to do different properties to kind of condense logs, and sometimes we have to expand logs, but this first example, we're just going to condense. So we're going to use the property, but we're going to use them kind of backwards from what we did up here. So we have the addition, same base. So what that means is I can rewrite this as log base 4, but then I have x times y on the inside because it was addition. Okay, and we can crank these out real quick. So here, log base 3, because that's what the bases are, but now we have subtraction, so it's 5 over z. And there you go. All right, this one's a little trickier, but really it's not too bad. So I'm going to kind of show you the long way, but then I'm talk about it a little shorter way. So we have log base 10 of x minus log base 10 of 5 minus log base 10 of z. So let's just focus on the first two. That would be log base 10 of x over 5. But then we still got this minus log base 10 of z. Okay, well, subtraction means that we would divide by z. Well, dividing a fraction by a number, or a variable in this case, really just means you're putting it in the denominator. Okay, and I'll kind of show you, or I'll just talk through it real quick. Anything that's being subtracted, when you condense logs, the things that are being subtracted are going to end up in your denominator. That's kind of your go-to thing. Okay, a little shortcut. All right, so then if we go to D, this one, we have to pay attention because there's a 3 in the front. We cannot condense these unless the log has nothing in the front other than maybe a plus or a minus sign. So we have to do the power property, which is move that 3 to the power. So this becomes x to the third. And now I have just subtraction, so I can rewrite this as log base 2 of x to the third over y, because again, subtraction gives us division. Oh, hold on, I'm trying, don't know my stylus. There we go. So x to the third over 3. All right, so here we got another one. We have a 2 in the front, a 5 in the front, nothing in the front for the log base 7 and 4. But yeah, so let's do that first. We're going to do log base 7 of a squared minus log base 7 of b to the fifth plus log base 7 of 4. All right, just like the other one, I'm going to do this in 2 steps, but you might be able to do it in 1. So I would say, okay, subtraction, a squared over b to the fifth, and then I'll have log base 7 of 4. Well, adding now means multiplication. So again, hopefully nothing too crazy there. And when we multiply by 4, it's 4 over 1. So that's why it's just 4 in the numerator. All right, our last one here, this guy, a little tricky because you're like, okay, there's no log in this guy. Well, what we can do is we can write log base 6 of 6. The reason why this is one of our like basic log properties is if these two things are the same, that means it's really 1. So now that's how we get a log attached to this 2, and then we could use the power property. So log base 6 of 6 squared plus log base 6 of x. Well, that'll simplify now because we have addition. Log base 6 of 6 squared, which, hey, guess what? I can write that as 36 times x. And there you go. All right, so there were some log properties. There are more, like I said, but these are the ones we focused on in this video. So thanks for watching. Have a good day.